Hello. Yes. So today let us try to revise thermodynamics, okay? Sir, I guess fans off just it will be better. I guess it's cool enough, right? Fans. So first let us try to look at the origin. As you all know that we are studying from high school that it is of Greek origin. This word is of Greek origin. Okay. From word thermi plus dynamics, where thermi gives the meaning of heat and dynamics gives us the meaning of force. So we all know this, I guess, right? So to make the subject more interesting, let me ask few questions, okay? Let us try to relate thermodynamics to real world. I guess my voice is clear now, right? So, okay. Sir, you cannot expect fan today. You need to bear me for 1 more hour, okay? So let me ask questions, okay? So from class, so you have been quite. So I'm trying to ask some interesting questions, else you will miss out, okay? So my question is, so from childhood we have been listening that do not waste energy, okay? Like this generation is wasting energy, so that next generation is not sufficient full of energy. So we might be hearing like you need to switch off your bike engines when red light is on in traffic. So you need to use pressure cookers to save fuel. How many of you know the reason for using pressure cooker to save fuel? No one? Okay. Okay. So let's see. So there are many summits going on to save energy, right? Hope you agree with this statement. So are you, I'm making sense? So all your phones, so come on, right. See, sir said that he will come in between if there is any sort of disturbance. So don't make sir enter the class, okay? I guess you know about sir. Sir told me that please call me if you find any disturbance, okay? So make sure that you maintain silence. So hope you are okay with that statement that this generation is wasting a lot of energy, so that next generation is deficit of energy, right? Hope you agree with this statement. So now let me make another statement. Hope you all are aware of law of conservation of energy, right? What does that mean? Right, okay. Energy can neither be created nor destroyed. So we learned this from our high school physics, right? So according to first statement, we are wasting energy. That is one side of a coin. According to second statement, energy can neither be created nor destroyed. Aren't they contradicting? See, first statement is saying that we are wasting energy, right? Second statement is saying that energy can neither be created nor destroyed. Aren't they contradicting? Yes. So which is right? Why people are crying outside that we are wasting energy? Are they fools? Have they gone mad? So first statement says that we are wasting energy. Second saying that energy can neither be created nor destroyed. Both are contradicting to each other. Which one is right? Because you studied in your textbooks, right? So why people are crying outside? Have they gone mad? No. No, both of them are right, and the relation between those two statements can be explained using thermodynamics. That is the beauty of thermodynamics, and I'll let you know the answer if time permits at the end, okay? So let me ask you some real world examples. See, I'm trying to make it as interesting as possible. So if you miss, I guess you will lose a lot. Hope you have seen such structures outside. Can you please name them? Tanks, water storing tanks, right? Hope you got it. So my question is, why such height is maintained? To store? To store more water. To create? Okay, still? And low pressure? Okay, still any answers, any guesses? Why do we maintain such height? Will people steal water if you don't maintain? Why do we maintain such heights? Huh? See, you can share your views individually. If you try to answer in groups, I cannot get your answer, okay? See, I'm encouraging interaction. So why such a height is maintained for tanks? See, try to relate physics to real world, okay? Then only you will enjoy the subject, else it looks like a burden. So can you, any guesses like why such height h is maintained? To increase? Okay, still, see, one answer is to increase water pressure. Any answers? Okay, so I guess it is similar one. So basically to maintain the potential energy, okay? To maintain the potential energy, which is equal to mgh, where m is the mass of water, g is the acceleration due to gravity, h is the height. So what are kinds of potential energy? See, this is one form of potential energy, which is known as gravitational potential energy. So other kinds of potential energy, can you please try to recall from other chapters as well? Right, electric potential energy, right, one still. Okay, so this is one of the real life application. So now I'm trying to draw a figure, so try to relate it. So basically I'm trying to check your fundamentals or brush your fundamentals, okay? So make it as interacting as possible. The figure may look funny, but a lot of physics is involved in it. See, 3 containers filled with water, okay? See now the question. Listen to the question carefully. Hope you can see the difference between these 3. So which among the following figure is correct? Sorry? B. See, you have been drawing this figure since your kindergarten, UKG, LKG kids also will draw this figure. Okay? So which among the following? B. So, okay, how many of you C? Please raise your hand. 1, 2, 3, 4, 5. Okay. How many of you B? So, how many of you A? A? No one A. So there is a great physics involved if you try to explain the figure, and the answer is B. See, the size of bubble keeps increasing as you go towards the surface, and I'll let you know the concept behind it if time permits at the end, because I'm here to basically explain thermodynamics. So you try to find in Google the way if you after going to home, okay? Nice question. So now let us get back to our thermodynamics. Okay. Basically, I have given those examples to make this seminar more interesting. So let us get back to our topic. So the moment thermodynamics comes into picture, the first two words are heat and temperature. So how do you define heat? Okay, form of energy, one statement. Still? Sorry, you are not audible. Someone is speaking here. Okay, it is a form of energy which travels from high temperature to low temperature if there is a temperature difference. So what is temperature? How do you define temperature? Right, degree of hotness is known as temperature. So I am trying to discuss the basic thermal properties of matter, and let us get back to thermodynamic laws in progress, okay? So ideal gas equation, can you please try to recall and answer me? What is? So units of P, units, Pascal, units of V, meter cube. What is N here? What is R? What is T? Temperature. What are units of T? Kelvin. So let us try to define each word. What do you mean by pressure? Okay, force applied per unit area. Okay, do you agree with this statement or any additions, subtractions to that statement? Hope you all agree. So let me give you a question. Open your notebooks. Okay. Consider a body. Come on, last benches. I will check your notes. Okay. At the end of the class, sir asked me to check their notes. Okay. So be careful. So consider a body of mass of 5 kg, surface area 5 meters square, at a temperature of 500 Kelvin. So what is the pressure on top surface, body of mass 5 kg at a temperature of 500 Kelvin, whose height is 6 meters and area of 5 meters square? So do you want options? So try to do the question. What is the pressure on surface? So this is a basic fundamental question. So option A 20. Do you want me to write that option? See, I'll pick options from you. A 20. Okay. Still, see any answers? See, the force makes an angle of 60 degrees with the perpendicular. What is the pressure on the surface, on the top surface? Come on, any options apart from 20? 10, huh? Okay. Still. See, how are you trying to do the question, okay? What is the formula for pressure? Huh? Force by area. Okay, then do. Why are you making? Huh? So option C, 0, my option. Option D, any options? 5. See, which among the following option is right? Okay, let us check. See, what do we mean by pressure? Force by area, right? So area, we know what is area? What is force? So 100 cos 61. Still, any options apart from 100 cos 60? Why not 100 sin 60? From the top, okay. See, it is just force by area, right? You can take any force. So the see why? See, how do we define pressure? Pressure is nothing but not just force per area. It is normal force per area, okay? See, you need to know that fundamental difference between force and normal force. In exam, only these fundamentals will be checked. No, everyone knows F by A, okay? Even 10th class student says that pressure is equal to F by A. So, you need to know the fundamentals. As the name of your academy, Rootsacademy, if you don't have roots, you don't get fruits. Roots, fundamentals. So, you need to have roots to get fruits that are results, okay? Hope you are clear with this question. Hope you understood the fundamental difference between the force and normal force, right? I guess from last benches, I am unable to hear any response. Got it, or do you want me to repeat? So now let us get back to our PV is equal to nRT. So where was it? So right, PV is equal to nRT. So we are done with pressure, Pascal. V for volume, you all know. What does this N stand for? What is this number of moles? I guess it falls in chemistry, but physics and chemistry are part of science, okay? So what does that N stands for, number of moles? Yeah, given weight by molecular weight. Okay, that is number of moles. What does R stand for? Value of R? Units. Joule per Mole Kelvin, okay. So you are okay with this T, right? Right. Now let us try to derive something from this PV is equal to nRT. In exam, he will play with this formula and ask infinite number of things. Let us try to look at what all can be derived from this PV is equal to nRT, okay? What is the basic difference between these two equations? Huh? R. What is R bar and R? How do you relate R and R bar? How do you relate R and R bar? Are they same? Are they different? Different. So how can we relate them? So how can we derive this equation from this or this from this, that? So if you try to elaborate this equation, you said that n is equal to given weight by molecular weight. I guess we got m here. PV is equal to mRT. So the relation between R and R bar, where m is not mass, it is molecular weight of the given gas. What is the value of R? See, that is value of R bar, right? R bar 8.314. What is the value of R then? 2.33. See, R is a property of a gas. It depends upon the molecular weight of the gas. You cannot generalize R like R bar. R bar is 8.314 for any given case. But R is not that way. It depends on the molecular weight of the gas. If you try to take R for air, it will be 0.28. Hope you have seen this number anywhere while solving the problems, okay? So this is the first equation if you try to derive from the PV is equal to nRT ideal gas equation. If you try to look at other equations, so you all know about Dalton's law of partial pressures. See, you may confuse why are we getting into chemistry, okay? Physics and chemistry are interrelated, they are branches of science, okay? So what is Dalton's law of partial pressure? Total pressure, exactly. P1, sum of individual pressures of a, exactly, non-homogeneous. See, let us consider a container with pressures P1, P2, P3, P4, okay? Total pressure is equal to P4. See, what is the volume occupied by 1? Let us consider it as total volume is V. What is the volume occupied by first gas? Will it be same or will it be sum of V1, V2, V3, V4? Is V1 equal to Vt or not? My question is straight. Is V1 and Vt same or not? See, you have completed your class 12. I guess 10th class guy can answer this. Hmm? Volumes always remain constant. The total volume occupied by gas will always remain same and is equal to the final volume. Okay? So we got pressure, volume, mass. This is nothing but sum of m1 plus m2 plus m3 and it goes on. Okay? So temperature, let us take this total temperature as T final. So will the final temperature be same or will it differ for each gas? What is the temperature of T1? Is it equal to Tf or not? Yes? Any no's? So how many of you yes? 3, 4, 5, 6, 7. Only 7. Out of, I guess, there are 50 to 60 students, only 7 are saying that final temperature is equal to same for T1, T2, T3. See, volumes and temperatures will always be equal. See, these are the basic fundamentals you need to know. Okay, if you want to get fruits, you need to know roots. So let us take gas 1, P1, volume M1, okay, N1, let us take N1, number of moles N1, R bar, T. Let us take final total value. See, this is for gas 1. This is for final total value. Final. So what is this sigma n? Total number of moles, okay? See, R bar is same as said before, 8.314, and it doesn't depend on the property of gas. So let us try to divide them. If we try to divide them, what will we get? Can you please help me? Please try to divide them and answer. What will we get? So can we write this in some other form? Exactly, mole fraction. Where mole fraction is equal to number of moles by total number of moles, okay? The ratio of pressures is equal to the mole fraction of a given gas. So let us equate the masses in similar fashion. So what is the sigma m? Sum of all masses of all gases, okay? What is this R equivalent? It is the equivalent of all gases, okay? This R is for that particular gas 1, and this R equivalent will equate for all gases. If you try to divide them, see, you better note down these statements. You can get direct questions in exam as well, so you cannot ignore them. I guess you are all preparing for mains, right? So I guess you will be writing at least mains even if you don't prepare. So try to get some marks so that it will increase your respect in society, okay? So what does P1 by Pt Mole fraction. So how can we write this R and R equivalent? We know that R is equal to R bar by M. R bar by M equivalent. Right? So if you try to cancel out, okay, right. So finally, if we try to derive the equation, we got a beautiful equation where we can relate mole fraction thank you. So the mole fraction is equal to ratio of molecular weights, where the numerator stands for equivalent molecular weight and denominator stands for molecular weight of first gas. We are trying to talk about first gas, right? See, you better close that, okay? So see this equation, you can expect a direct question from this equation. See, everyone knows PV is equal to nRT. Even 10th class student knows PV is equal to nRT. If you try to put values in it, you will get. But the questions, the kind of questions you get is such questions you get in mains and advanced. So you need to derive all these things. So you don't have such time in exam. So you need to be prepared. So you need to know at least how do we get to such equation, okay? So if you try to talk about PV is equal to nRT, I guess this is sufficient. So let us try to get back to our, so some more thermal properties of matter, okay? So what is Cp? Cp, Cv, ratio of specific heats. So what is Cp stand for? So the specific heat at constant pressure. What does Cv stand for? Specific heat at constant volume. What does gamma? Ratio of specific heats. So Cp minus Cv R. Okay. Hope you are all aware of these equations, and I'm not trying to get into details because we have a lot to cover, okay? So what is value of gamma for monatomic gas, diatomic gas, triatomic gas? For 1.33 for monatomic. So what is monatomic gas stand for? What do you mean by monatomic gas? What does diatomic atom stands for? Examples of monatomic, diatomic, triatomic. H plus for what? Monatomic, okay. Diatomic. Diatomic, famous Triatomic? Ozone, okay, you have many examples. So, value for monatomic gas 1.67, diatomic 1.4, triatomic 1.33. See, you need to be aware of all these basic fundamentals, okay? I'm not getting into the problems only. I'm just trying to revise fundamentals. So these are thermal properties of matter. What is value of Cp for water? So let us first talk about air, okay? Cp of air. What is Cp of air? 1.005. What is the value of Cv? In general STP, like in general conditions, what is the value of Cv? 0.718, I guess. So what is the value of Cp for water? See, this is for air, right? What is the value of Cp for water? Huh? What are values of C for water? 4 point? Is it Cp or Cv? What is Cv then? So value of Cp for water is 4.2, okay. What is value of Cv for water? Any guesses? No guesses. At least guess. 4, okay. 4.2 for Cp and 4 for Cv. See, this Cp and Cv will only exist for gases. For water, Cp and Cv is equal to C and is equal to 4.2. So, for water, both at constant pressure and volume, it hardly differs. So, it is 4.2 and we cannot define at constant pressure and volume for liquids. Cp and Cv exist only for gases. So, let us try to take the next topic. That is, let us get into our subject. Still we haven't got into your subject. You people are thermal equilibrium, okay? So, thermal equilibrium. So, what do you mean by equilibrium? What are kinds of equilibrium? Different. Okay, chemical equilibrium 1. Okay. Still any other kinds of equilibriums? Mechanical equilibrium. You have thermal as well. Mechanical, thermal. See, without mechanical equilibrium, you cannot solve questions of mechanics. You need to be very much accustomed with this mechanical equilibrium. So, what exactly, see, equilibrium is a state. So, what does that state stand for? Like, when we can say that a body is in mechanical equilibrium or thermal equilibrium or chemical equilibrium? How do we differentiate? Okay. One of your friends says that if temperature remains constant, we can say that it is in thermal equilibrium. Okay. How about mechanical equilibrium? See, at least you can make a guess if you don't know. So when okay, when there is no forward and backward reaction, you are trying to say that, okay, yeah, perfect. When there are no forward and backward reaction, we can say that it is in chemical equilibrium. So thermal equilibrium, we got to answer that the temperature remains constant. How about mechanical equilibrium? When we can say that a body is in? When net force is equal to 0. When sum of all forces acting on a body is equal to 0, then we can say that it is in mechanical equilibrium. Thermal equilibrium, temperature is constant. And chemical equilibrium, there are no further reactions. See, if you try to summarize these three statements in one single word, we can say that properties, if we try to be more specific, macroscopic properties of substance or matter do not change with time. See, if properties do not change with time, then we can say that a body is in equilibrium. Hope this statement works for all this, right? So if we try to generalize this statement for equilibrium, the properties should not change with respect to time. So now let us get back to our thermal equilibrium. So to talk about thermal equilibrium, let us get back to our laws. So how many laws do we have in thermodynamics? 3 laws, okay. First is Zeroth law, right? So what is Zeroth law? That is conservation law. What is Zeroth law of thermodynamics? I guess you have written your board exams, right? 12th class. Huh? Sorry, I didn't get you. First law, okay, you want first law. You will get later, okay? So what is the highest mark you got in your 12th class? Out of physics, it will be for 60, right? Anyone? How many 60s? These many 60s? Zeroth law of thermodynamics. Yes. See, I know that you all people know, but you are not expressing. If bodies A and B are in thermal equilibrium and bodies A and C are in thermal equilibrium, then we can say that these two bodies are also in thermal equilibrium. This is about Zeroth law of thermodynamics, okay? It's so simple and very easy. Let's try to look at first law of thermodynamics. So what is first law of thermodynamics? Can you please try to recall? First law of thermodynamics. Heat supplied is equal to change in internal energy plus work done. Okay. So what are units of heat? Joules, okay. What are units of internal energy? Joules. What are units of work done? Joules, okay. So all these three have same units, and we can also say that first law of thermodynamics is also known as law of conservation of energy, that we have been talking in first sentence of this seminar. So what is the difference between heat, work and internal energy? Are they same because they have same units, or are they different? Any differences for heat, internal energy and work done? So you were saying that in earlier heat was form of energy, right? See, what is internal energy? What do we know about internal energy? Okay, sum of all energies within a body is known as internal energy. Okay. See, first let me try to define intensive properties and extensive properties. Okay, before getting into that, let's complete this. So how do you define work done? We can write this as P into delta V, right? Hope this is correct. P into delta V, right? We all know work done. See, heat and work are not properties of a system, and internal energy is a property of a system. From first law of thermodynamics, the outcome is internal energy. See, this is for a process. Okay? If you try to write the FLTD for cycle, it will be net heat supplied is equal to net work done, because internal energy, sum of internal energy for a cycle is 0, as initial and final points are 0. Right? So let's try to okay, right. Okay, right. So this is about first law of thermodynamics. Now let's try to solve some problems. Okay, come on, open your books, right, pens on. So let's try to solve some problems. Actually I have brought few questions for you. So come on, everyone, note down. An ideal gas. See, your notes will be checked at the end, so no worries. Sir will come and check. So please note down the question and try to solve. An ideal gas undergoes the following cycle. See, an ideal gas undergoes the following cycle, okay? So try to note down. Ideal gas undergoes the following cycle. It's heat interaction, I guess you are noting down the question, and please note down the question. Like, see, an ideal gas follows the cycle and the heat interaction for process A, B, BC and C are given. Work done by BC on gas is 400 joules. Find internal energy at B and C. Question 2. See, this is a basic fundamental question. You can direct formula application. So an ideal gas undergo the following cycle. Process A to B, B to C, C to A. And the heat interaction, QAB is 500 joules. BC is 100. Sorry, BC is 0. And CA is 700 joules. Work done on gas at BC is 400 joules. So the question is find internal energy at B and C if internal energy at A is 1500 joules and work done in the process C to A. So try to answer these questions. Internal energy at A is 1500, okay? Internal energy at B and C are being asked. Come on, open your book, solve. Have you done? Same, Show me on paper. See, there are 3 questions here. One is internal energy at B and C, and the other question is work done in C to A. Okay, so start solving, man. Copying question doesn't end the process. Solution. See, there are 3 questions here. You complete all those 3. Are you done? Okay. So tell me your answers. Okay, what are your answers? 2 kilojoules, okay. Okay. 1.6. Okay, what is it work done by CA? Minus 400. Okay, any other answers apart from this? One of your friend got these answers. See, these are direct application of your formula. There is nothing big logic here. You can directly apply first law of thermodynamics and solve. See, these are direct applications, right? Have you copied the question? No idea. So see, this is very basic and simple question. There is no much logic involved here. So one of your friends said these answers. So do you agree with them? Shall we check? Have you copied down the question? Then start solving. There is direct question. This is direct application of first law of thermodynamics. You better keep your mobile inside. Sir is observing everything. So people in the last rows, any answers? Huh? So let's check. So what was the question? The question was internal energy at B, right? So let us take it as B to C. We know UA is equal to 1500. See, what is the value of work done from A to B? Why? Yeah. So work done from A to B is 0. So what is your answer? Sorry. 500, right? So you are right. So one of your friend got correct. So this is the same process followed for other problems as well. Hope you are okay with this. Do I need to explain the other problems also, or I guess this is sufficient, right? So now let's go to another question. See a process. See, try to note down the question. A process undergoes, an ideal gas undergoes the following cycle. Okay? And try to find the work done A, B, B, C, C, D and D and find the total heat rejected. So how do you solve? I guess this is direct application of first law of thermodynamics. So answer me work done by AB, BC, CD, DA and net heat rejected. See, you are supposed to solve these questions within 3 to 4 minutes, okay? Make it fast. See, these are oriented for mains, right? See, you don't have these many questions in Eamcet. You have only one question among them, okay? I'm trying to cover the entire concept, okay? Try to make advantage of it. Okay, there are 5 questions. Solve everything. Huh? Answer for this? 0. Net heat rejected 0. Okay. See, come on, show me. What is work done by AB? CD. Let's check. Try to solve this. AB 100 joules, okay. BC 0, okay. CD minus 200. How about DA 0? So what is this net heat rejected? There are 5 questions. See, these are basic fundamental questions. So do you want me to come there and check, or are you doing? So I'm coming. At least try to copy questions and solve, okay? Sir will come next. No worries. Have you copied question? Then try to solve. ఏమైందని? I guess you can solve them, right? ఏముందంలో direct formulaనే కదా. See, don't try to just copy, try to solve. Come on, man. So, copy a question, copy. Where is your book? Give him a paper. Sir.
Eamcet ఉందండి ప్రిపేర్.
Put your mobile inside. అయిపోయిందా? చేయవా మరి ఆలోచిస్తున్నావు? Where is your book? See, come on. What is the answer for heat rejected? Minus 100, huh? Okay. So how do we solve? What is work done by AB? P delta V, right? What is pressure? Pressure is constant for A and B, right? That is 1000 kilopascal. What is delta V? 200 minus 100. So kilopascal, kilo. See, this is in centimeter cube. We need to convert it into meter cube, okay? So similarly, try to solve the other questions as well. So option 100 joules is correct. So how about BC? So work done by BC. Why? What is work done by BC? Huh? 1000. Why 1000? See, just try to apply this formula for work done for BC. Work done for BC, 0. So what is work done for CD? Same P into delta V, okay? Delta V, final minus 100 minus 200, minus 100. Minus 200 joules. What is work done for AD? 0, right? So then what is the total heat rejected? Minus? How? So from first law of thermodynamics, right? What is net work done? Minus 200, 100, minus 100. So I guess you are okay with this question. So this is about first law of thermodynamics. We are done with the questions. Now let us try to look at some process, okay? Have you solved? ఏంటి సార్ వస్తేనే సాల్వ్ చేస్తారా మీరు? చెయ్యి, ఏమైంది? సాల్వ్ చేయి. ఎగ్జామ్ లేదా మీకు? ఉంది కదా ఎగ్జామ్. ఏది? యూ రిజెక్టెడ్. అర్థం అవ్వట్లేదా అది? కనిపించట్లేదా? షార్ట్ కట్ రాశాను నేను. ఓకే, కిందికి కనిపించట్లేదు. మీకు క్వశ్చన్ ఓకే కదా మీకు? Okay, hope this question is clear. Now let us try to look at some process, okay? Excuse me. So what are different types of process involved in thermodynamics? Can you please name some? Adiabatic process 1. Next, isothermal. Isobaric. Isochoric. So how do you define these four processes? So what is the specialty of these four processes? Adiabatic process. What is work done by gas? See, in adiabatic process, net heat interaction will be 0. In isothermal process, change in temperature will be 0. In isobaric process, in isochoric process, okay? So try to draw these four processes on PV graph, okay? Try to represent them on PV graph, these four processes. Try to represent them on PV graph, those four processes. Try to represent them on PV graph. You please come, sit in first bench. I guess you don't have sufficient place, come. You have place over there. You have one more seat. Who is willing to come and sit there? Come on. Sit there, take your book. Go and sit in first bench. Come. Don't delay, come on. Represent them on PV graph. Sit there, first bench. Delta? V తమ్ముడు నువ్వు ఎగ్జామ్ పెట్టుకొని వియా యువ అని అడుగుతున్నావా నన్ను? పైకంటే సార్ ఐ డోంట్ నో హౌ టు డూ దాట్. You go and do. Okay. Someone help me. వచ్చా నీకు? Yes, it is clear now. So try to represent them on PV graph. All those four processes should be represented on PV graph. ఏంటి ఏం చదువుతున్నావు ఇది? యూ బెటర్ క్లోజ్ దిస్, ఓకే? కనిపిస్తుంది కదా ఇప్పుడు? చలో మరి వస్తావా ఫస్ట్ బెంచ్కి? షో దెమ్ ఆన్ PV గ్రాఫ్. ఎప్పుడు వచ్చినా అన్న? సి మొబైల్స్ అలౌడా మీకు? Come on, try to draw them on PV graph. వచ్చారు కన్నా గీసారా బోర్డు పైన? ఏది రాసుకోవాలి. So try to show them. So first let us try to pick this C isobaric. How does it look like? How does the isobaric line look like? Straight line, okay. Because pressure is constant, it is parallel to volume axis. So how does isochoric look like? Vertical. Okay. Right, this is C, this is D. How about A and B? Curve, okay. How about adiabatic curve? Okay. Which one is A and which one is B? So this is A, this is B, right? So what is the slope of line A? Slope of adiabatic process. Which one? Does it look like a straight line? Then so what is the slope of adiabatic process? Is it positive or negative? First let us try to segregate. Negative, positive? Negative. Okay, what is the value of slope of adiabatic process? అడగద్దంటావా? See, adiabatic process we can represent by PV power gamma is equal to constant, right? Isothermal, PV is equal to constant. Isobaric, volume is equal to constant. Sorry, pressure is equal to constant. Isochoric, volume is equal to constant. So slope of adiabatic process is negative, and what is its value? Minus, sorry, you are not audible, someone is speaking. Slope of adiabatic process. Is this the first time are you hearing or do you know? Slope of adiabatic process. Try to derive. See, what is slope? Dy by dx, right? Right? So what is y here? P. dp by dv. So try to find dp by dv for adiabatic process and isothermal process. Slope of adiabatic and isothermal, come on. See, try to derive slope of adiabatic process and isothermal. See, I even gave hint, dy by dx is equal to dp by dv. Try to find dp by dv. I want slope, value of slope. Value of isothermal and adiabatic. ఏ ఎగ్జామ్ రాస్తున్నాను? ఏపీ ఎంసెట్ రాస్తున్నావా? సార్ వస్తే తప్ప రారా మీరు? మీకు ఎగ్జామ్లో వస్తుంది ఆ క్వశ్చన్, నేనేదో టైంపాస్ చెప్పట్లే. పక్క అంటే నేను సెట్ చేయలే కదా పేపర్. డిపి బై డివి ఎంసెట్ రాస్తున్నావు నువ్వు, మెయిన్స్ రాయట్లేదా? మళ్ళీ వస్తుంది కదా మెయిన్స్. ఓకే లేదా ఏ బ్యాచ్ మీ ఇప్పుడు ఇందులో వస్తాయి క్వశ్చన్స్ ఇందులో ఇది వద్దా సార్ సార్ జేఎన్టీయూలో బ్రాంచ్ బట్టి ఉంటుంది మీకు 2000 ర్యాంక్ రా minus see you cannot tell value in terms of P and V. Try to say in terms of P and V. Minus B by V. Correct అది see if we try to differentiate. So how do you differentiate? What is the chain rule? First function, derivative of second function, plus what is the differentiation of constant? 0. So to get dp by dv, see the slope of isothermal process minus P by V. In the similar way, if you try to find for adiabatic process, come on, try to find slope for adiabatic process. Minus gamma P by V. So, whose value is more? Either value of isothermal more or adiabatic more? The magnitude of gamma into P by V is more as value of gamma is greater than 1. It is 1.33, 1.67. So if you try to take any gas, the value of gamma will be greater than 1, okay? So you get dp by dv is minus P by V. See, okay, we have minus here. So thus we proved that this is adiabatic, this is isothermal. See, what is the slope of this D, isochoric slope of D? Slope of isochoric process on PV graph. Slope of isochoric process on PV graph. Slope of isochoric process on PV graph. Infinity. The slope is infinity and slope of C, that is isobaric process, is 0. So let us try to derive work done for these different processes, okay? Try to keep your mobiles inside. Bag lo, but keep your mobiles inside. ఇక్కడ పెట్టుకొని రాయరా, ఇక్కడ పెట్టుకొని రా. నేనేమన్నా రాయి. Try to derive formulas for work done for isothermal, work done for isobaric, work done for isochoric. Work done for adiabatic. I guess you all know this and try to derive them now. సార్ 11:30 అన్నారు కదా, అయిపోయిందా? అంటే సార్ చెప్పమని నేను వెయిట్ చేస్తున్నాను యాక్చువల్లీ మీకోసం. అయిపోయిందా? ఓకే, 2 minutes ఇది క్లోజ్ చేసి. సో ట్రై టు డిరైవ్ దీస్ ఫార్ములాస్ and we will end the session today. Okay, try to derive this formula. This is the last part of your so called today's seminar. Try to derive them. At least try to write the formulas for all those 4. వచ్చా ఫార్ములాస్? గుర్తు తెచ్చుకో. ఎంసెట్లో వస్తాయి ఇవి, ఎంసెట్లో అడుగుతారు ఇవి. మరి రాయి చూస్తే సరిపోతుంది. డైరెక్ట్ ఫార్ములాస్ కదా అవి. ఏంటి ఎన్ని వస్తాయి ఇందులోంచా? డిఫరెన్స్ ఫ్రమ్ ఇయర్ టు ఇయర్ ఫార్ములాస్ అవి వచ్చా? అవి డైరెక్ట్ ఫార్ములాస్ అవి. అందులో ఏముంది పైగా అన్నాను. At least try to write the formulas. Formulas ready? So tell me the formula for isothermal work done. Okay. So what is the work done for isobaric? Okay, what is the for isochoric? 0 why? Okay. What is See, actually you need to know how to derive them, okay? So at least try to remember the final results. కనిపిస్తుందా నీకు? ఇప్పుడు కనిపిస్తుందా? So let us try to end our class today. So if you try to recall what all had happened. So we tried to cover fundamentals, ideal gas equation. I'm trying to revise. Okay, we had covered ideal gas equation and its derivatives. we had done a couple of questions and we have spoken about thermodynamic equilibrium, zeroth law and first law, okay? And we tried to derive the formulas. So thank you for cooperating. Have a nice day.